Here's our agenda. I'm going to do a quick overview of objective quality metrics, the ones that I work with, the tools that I work with, and then we'll look at how you can use those objective quality metrics to help accomplish things in the encoding or configuration process, like configuring your X264 encodes, measuring adaptive groups, choosing the optimal resolution for your video files, and then we'll talk a little bit about the computer requirements for doing the type of testing that, that's involved with this. Shameless plug. I started doing a lot of the book, Video Encoding by the Numbers. Basically, what grabbed me to do another book on compression was that once you have objective quality benchmarks, you have the ability to take opinion out of the decision process. So 3 or 4 years ago, when you asked somebody about CBR versus VBR or about, what keyframe interval is the best, you had a bunch of different opinions out there, but nothing was really fact-based. Everybody's, this is better, this is better. But what you can do with objective quality benchmarks is you can say, okay, well, which is better? Is keyframe interval of 2 higher quality than 10 or 1, or CBR better, and how much better? So the ability to quantify all this stuff was very fascinating to me because that's how I like working. If I have a client paying me to configure their streams, I want to say, don't do 7 megabits a second because it's only 0.5% better than 5.5 megabytes per second. So when I talked about video encoding by the numbers, every recommendation in the book is backed up by some objective quality benchmark. So there's very little opinion. It's all, and you'll see a lot of the tables from the book are included in the presentation. Anyway, I think I have 3 books left. It costs, it's pretty current. I published it in December. It costs on Amazon $50, so the show special is $40, and you get the PDF, which costs $40, and I'll send that to you as well. So it's a pretty good deal if you're interested and if you're just here chilling. That's fine. But I've got 3 books left, and anybody who's interested, just come to me after the show. So what are objective quality metrics? They are mathematical formulas that attempt to predict how the human eye would rate the video, right? So we encode our videos because we want optimum quality, but you can't hire a group of people to evaluate every decision that you have to make. There's literally hundreds of decisions you make when you encode your video, and now those hundreds of decisions have to be made over multiple files in an adaptive group. So there's really no way possible to hire humans to make evaluations that say, okay, this is better, this is worse. So what objective quality metrics try and do is they try and predict how human eyes would subjectively evaluate the decisions that you're making. And some of the examples are, the most common ones you heard about are peak signal to noise ratio, PSNR, structural similarity index, or SSIM. Video quality metric is not that well known, and then SIM+. So these are examples of objective quality metrics, and the new one, which we'll look at in a second, is from a company called Netflix. You may have heard of it, but it's a new metric called VMAF, and that is from Netflix. And wanted to talk about subjective versus objective visual quality analyses. So all the way on the left, if you want to do a standards-based analysis of any kind of video comparison, there are standards for that, and that's the gold standard, right? I mean, that's you bring people in a room, you sit them a certain distance from a TV, you use side-by-side TVs, you use triple-blind studies. So all that's very specified if you want to do that. It's also very time-consuming, very expensive. All you want to know is which keyframe interval to use. So that's kind of the standards-based, and then the informal is the golden eye. And the golden eye, is kind of what I used to do. You'll see an example of that, where you kind of like stare at the video side by side. But what got me into the objective quality side was, I think it was 3 summers ago, I had a consulting agreement to help a company choose an HEVC codec. So we set up the test grid, and it was going to be something like 180 different comparisons. And if you have 180 different comparisons, you can't do this, and you can't even really do this. Not on any kind of time-efficient or even reasonably effective basis. So that's when I started using objective quality metrics. And what we're doing is, this is the best, this is kind of the second best, although it's pretty cumbersome. This is the third best, and this is, so if you look at a model like here, like PSNR or SSIM, these are pretty much tuned to understand the differences between the source and the compressed file. So what they do is here's the source file, here's the compressed file. What are the differences? And differences, you add up the differences, you run some math on it, and that produces a score. The problem is, a lot of times those differences aren't things that people can see. And a great example of that is, attention-focused compression. So imagine you had a big frame, and I'm in the frame, and one compression technology was able to say, hey, all we care about is what's going on in the center, so we're going to blur everything else. And another technology said, no, we got to keep everything sharp. So the math-based, pure math-based with no perceptual quality portion would say the attention-weighted portion was bad because all the background was different than the original. But really, if you include perceptual quality analyzer, if you look at the perceived quality by the viewer, you would say, well, that approach is better because that's all the people are seeing. So these are all math-based, and then the higher quality analysis tools like VMAP from Netflix and SimPlus and some of the others they include a level of perceptual quality analysis. They say, okay, this is how people subjectively compare these types of videos, so we're going to include that in the formula. So what I did in the book is I pretty much focused on this category here. And I focused on this category here because at the time, tools that delivered these were started at $4,000 and can go as high as $20 or $30 or $40,000. So it's I couldn't get access to those tools, and I was writing the book for people who would might want to do the same thing that I'm doing. So I'm using PSNR primarily in the book, and in this presentation more relevant. And why are you using a perceptual quality analysis that's not optimal? Because in my view, in the land of the blind, the one-on band is king, right? I mean, it beats doing nothing. And in point of fact, Netflix used PSNR to gauge their compression decisions until June of 2016. So they came up with VMAP after that because that was better. So it's not like PSNR totally stinks, it's totally irrelevant. I mean, Netflix used it to drive their encoding decisions. And every quality comparison that Netflix produces these days for HEVC or for VP9 always includes PSNR data. So I don't think PSNR data is totally irrelevant. I think it's pretty valuable. It's also very accessible. You can get it from FFmpeg for free, or you can get it with the Moscow University tool we'll look at in a second for $999. So if you want to do this stuff yourself, you can do it with PSNR. The SimPlus tool is it's $4,000. The PQA and the DMOS tools from Tektronix are $11,000. So that's going to be accessible to some people. It's not going to be accessible to everybody. And then VMAP is open source, but until this past weekend, I didn't have a way to access it. And there's a company called Hybric who's out on the show floor that has implemented. So Netflix did this algorithm. They open sourced it, and Hybric is a cloud encoding company who now has the ability to produce VMAP scores. And one of the things I'll do when I get back home, I did a bunch of VMAP analysis, and when I get back home, I'll have time to see how that maps to PSNR analysis. And I don't know what that's going to look like, but we're going to look at some comparisons of that right now. So again, this kind of talks about what I just talked about. We've got the noise computation. Here's the reference video, that's the source. Here's the test video, that's the compressed. How much noise is there in the file? How much difference is there between the original and the original and the compressed? And that's these metrics here. And then more perceptual adjustments, that's more advanced metrics. And then picture quality measurement, where you look at things like attention weighted, then that's the more advanced algorithms that are over here. And then when you're looking at a quality metric, you'll often see a chart that's very much like this. And this is again, the point of an objective quality metric is to predict how a subjective eye would rate the video. So this is you would see a plotting of here are all the scores for the quality metric. Here's all the scores. So you rate 10 videos, and then the objective quality metric comes up with 10 scores, and the human subjective metrics come up with 10 scores. And then you plot those scores. And then in a perfect world, if you had the perfect objective quality metric, the line would look like this. Every point on the line would be equal for the subjective quality metric and the objective quality metric. And then that'll make a lot more sense when you look at something like this. And here you're seeing, okay, correlation with human DMOS, so human difference mean opinion score. This line looks a lot like this line, which is the theoretical perfect score. So these are the types of graphs that you see when you look at the predictive nature of an objective quality metric. So Tektronix is selling ADMOS, and they're saying, there's a pretty good correlation here. They're selling against PNR, so they're saying there's no correlation here. I don't really find that to be true, but this is their, and this is from a company called SimPlus. They sell the SQM, the SimPlus quality of experience metric, and you see again a better correlation here than PSNR. And this looks more accurate to me from a PSNR versus other metrics. It's not perfect, but it's pretty correlative. And I'm not trying to pick a Kodak here. I'm trying to say, how much worse does your video look if you use a keyframe interval of half a second as compared to 10 seconds? How much better does it look if you go 7 megabits per second versus 4 megabits per second? And you really are thinking about error there. We're not doing anything that's really funky from a perceptive standpoint. And then here's just my metrics. This is what I think about when I look at a metric. Here's PSNR, MSSSIM, SimPlus, PQR, ADMOS. Haven't updated for the Netflix metric. And this, basically they get better as you go to the right, but they also get costlier as you go to the right. And that's kind of what I started with. These are definitely better. If you can afford them, get them. But you can get PSNR for free. And I really think that the predictive nature of PSNR is better expressed over here than what we see over here. And I found it to be pretty true. So basically what I'm saying is, I'm not full of beans. All the rest of this presentation I think has some value because it's proven with my subjective evaluations. And this is what I did. This is kind of a mini comparison between the metrics. So I had 3 files, 720p, 1.5 megabits per second, 3 megabits a second, and I encoded baseline, main, and high, and then I measured with the different tools, and then I wanted to see how those tools rated those videos. So this is peak signal to noise ratio, and we're seeing Syntel, Talking Head, so there's 3 encoding tools, 3 source videos encoded to using the baseline, main, and high profile at similar data rates. Okay, so what we're seeing here is that the baseline, PSNR, higher scores are better. So baseline in this video is the lowest quality, baseline in this video is the lowest quality, and baseline in this video is the lowest quality. No surprise there. Here's the high profile. And if you've encoded a lot of video, you know that the jump between the baseline and the main profile is a lot more significant than the jump between the main profile and the high profile. And that's what PSNR is showing us. So this is the baseline, free objective quality metric. This is structural or multi-scale structural similarity. This has some perception in it as well. But again, we're seeing baseline is the worst, baseline's the worst, high is the best, and the difference between main and high is much less different than the difference between baseline and main. This is SimPlus, and same kind of pattern. It's basically showing one's, baseline's the worst. Picture quality rating is lower scores are better. So here we're seeing this is the best. This is the worst. This is the best. Again, same pattern. And attention-weighted DMOS, same thing. Lower scores are better. So here we're seeing a similar pattern. So this is kind of the point of these slides is, PSNR delivered results that were pretty similar to the higher quality metrics. Baseline was always the worst. High profile was always the best. And maybe there's some variation in the scale, maybe some variation in how much they differed, but the general scores are correct. And I'm guessing when I compare PSNR to VMAF, I'm not going to see something where they say, in effect, baseline was the best quality. There's not going to be any shocks. There may be differences in scale. VMAF feels a lot more sensitive, so it may be this is a lot worse than this, but it's going to show baseline is the worst, main is better, high is best, and the difference between main and high is, So I'm going to do the work, but I don't think we're going to see major differences. And all that's a long way of saying, again, that the PSNR-based evaluations that we're going to look at, I think are have merit. They're not the best. if you have access to BMAF or some other higher quality metric, I would definitely use that. But the theory is kind of the same, right? It's like you do the work with the objective metrics, and then you take the information that they tell you, and you make a compression decision. And then, this is what I used to do. Literally until that consulting contract, what I used to do is I'd encode 4 videos, and I'd put them in a Premiere Pro timeline, and then I would, compare the frames. And it was very, very time consuming. It was very, very imperfect because a lot of, you miss things, you pick the wrong frames, you play the video side by side, and you try and look at it that way. But it's an imperfect way to do it. The objective quality metrics allow you to do it at scale, and they also give you a lot better information. So this is going back to that consulting agreement. I was able to say this is one of the 15 test cases, I think. And we tested with 3 different metrics. But in a table like this, it's really easy to see that codec B was the best alternative, right? Because green is good, red is bad, or here in this case amber is bad, and then red shows anytime there's a difference between these 3 codecs that exceeds 5% or so. So when you get the objective metrics, you just get access to a ton more data that you can really, really use to understand how the quality compares. And then this is the Moscow University tool. And what this does is this is a spike. So we're measuring quality for 2 files. We see a data spike here. I can go in and look at that frame and back up the objective conclusion looking at the exact frame itself, where I can go to the source video and play it again. So I don't think you ever want to make a decision based totally on numbers, but I think you want to use the numbers to point you to particular spots in the videos where you may want to focus on it. And if you're trying to make large-scale decisions like this, you literally can't do it with subjective means. And then again, the point is trust but verify. Never rely solely on objective test results. Compare the files yourself. Nothing's more embarrassing than this actually happened to me. I had a file that's graded better from a PSNR standpoint, but it was bluish tinged. So it's like the one file that rated worst, was normal tinge, and it had a higher score than the bluish tinge one. I don't know how that happened, but I'm really glad I checked it, because if I'd showed that to a client and said, hey, this approach is better, it really would have been embarrassing. So I think you really, don't think the objective metrics preclude the necessity to use subjective at some level. So the tools that I use really quickly, I use the Moscow University tool. This is a $1,000 tool. And I typically use PSNR because, at the end of the day, everybody understands PSNR. So if you're talking to a client, I like VQM for some uses. I like SSIM for some uses. They're probably better metrics, but the client understands PSNR. That's what they want to see. And I also use a tool called the SimWave Video Quality of Experience Monitor. Here's the VQMT workflow. You load the source file. You can include 1 or 2 encoded files. You choose your metric. There's like 20 metrics you can choose from. Then you click Process, and then this is what you get back. And I love this, right? You can look at the scores, and this is VQM, so lower scores are better. Red is the first video you loaded, or blue is the second video. So you can really tell not only what you can tell where the differences are, and you can tell the extent of the difference from this graph. And again, if you wanted to see, so this is the entire file. This is this chunk of the file. Red's first file, blue is the second, and then you can slide through the frames here, and then you click here to show the actual frames. So if I wanted, if this frame showed up as a spike, I'd click this frame, and then I can look at the original, I can look at the first compressed and the second compressed. When you're looking at A/B comparisons, it's a wonderful tool because you can, it really points you to the differences in the files, and then once you see the differences, you can just click and look at the frames themselves. And then you can move, you can use the arrow keys to go back and forth and understand, and look at the frames themselves to understand what the difference is. So the pros, it's affordable. It's $1,000. We talked about the visual nature of it. It's got multiple algorithms. You can read my review of the tool. It's about 2 years old now here. I should say this presentation will be online on my website. Write down streaminglearningcenter.com. I'll put it up there in the next day or so. I apologize for not being there now. The negatives, it can only compare files of like resolution and frame rate, and scores don't correlate with subjective perception. What I mean here is with the next tool we're going to look at, the scores correlate to perceived or predicted perceived evaluation. So the Sim Plus tool, if the score is 90, they're saying people will view that video and rate it as excellent. If the score, so if it's 80 to 100, it's excellent. If it's 60 to 80, it's good. If it's 40 to 60, it's fair. So the ratings, you understand from the rating how they think the viewer will rate that subjectively. You don't get that with PSNR. You don't get that with any of the metrics included in this tool. So since SQM Overview, again, this is the $4,000 tool. You can read my review of the tool here. We talked about the correspondence with human perception. It's based on the SimPlus algorithm that was invented by the inventor of SSIM. It also allows you to predict ratings on multiple devices. We know that, a video that looks great on a 4K, a video that looks good on an iPhone may not look great on a 4K TV. And one of the cool things about this tool is it lets you rate quality based upon different TVs, different monitors, different mobile devices. So you really get a sense that you really get a score back that reflects the quality on the devices that you care about. So Netflix's tool doesn't do that. That's something they're working on. The Moscow University tool doesn't do that at all. So I mean, you really, intuitively, we know that video that looks good on a cell phone, you can have 360 or 640 by 360 video that looks good on a cell phone. Throw it on a 4K TV, it's going to look awful. So PSNR doesn't really comprehend that, and the VMAP tool doesn't currently comprehend that. And this tool does. The workflow here is pretty much the same. You load the test file, you load the source file, you choose the platforms for rating. So you'd say, okay, I want to look at, I care about how this looks like on a 4K TV. Or here we're looking at a, these are all TVs. So they've got a bunch of phones, a bunch of TVs. Some are 4K, some are 1080p. And here's the GUI workflow. So you can actually, this is the original file, and then you can toggle between the compressed file and this visualization here, which shows the differences between the compressed and the original file. And these are the scores on an ongoing basis. So this is it's playing through the file in real time and calculating the scores. And this is what you get back from the SQM tool. So this is the Sony X9. That's a television, and it shows you the maximum, minimum, and then the mean, and the mean's the score you care about. Here's another TV. Here's a notebook, and there's always a standard score that delivers back. And you can have, again, you can have phones, you can have tablets, you can have computer monitors, you can have TVs, you can have 4K TVs. And then you can visualize the differences here. This is not showing up well, but you can, similar analysis to what we saw with the Moscow University tool. And you can compare files one-to-one. And both of these tools, I should say, have command line components. So if you don't care about the visualization side, you can set up command lines and just run them overnight. And that's, if you're doing a lot of files, that's what you're going to end up doing. So what do we like about the SQM tool? It's got a unique quality algorithm, SimPlus score. It incorporates a lot of perceptual quality things that you don't get with any of the metrics in the Moscow University tool. Scores correlate with viewer perceptions. If it's a 90 score, you know that's going to, they're saying it's going to rate excellent. They support multiple devices, multiple resolutions, which means you can compare a 640 by 360 video with a 1080p video. Can't do that with PSNR. You can do that with this tool. And sooner it'll support multiple frame rates. One question is it better to do 320 by 240 at 15 frames per second at your low end of your scale, or is it better to do 320 by 230 at 30 frames a second? And there's no tool that gives you the ability to compare those today except for this. Right? So what is the effective frame rate on perceptual quality? They've kind of factored that into their metric. Does that make sense? I mean, whenever I talk to a client, it's always, what do you do at the low end of your encoding ladder? Do you cut the frame rate, or do you cut the resolution? And there's no tool that lets you compare that from an objective metric standpoint. PSNR can't do it. VMAP can't do it. But this tool lets you do that, which is kind of nice if you're looking for evidence to make a decision. So now I'm a big X.264 fan. I do pretty much all my encoding now with FFmpeg. And now we're going to talk about how objective quality metrics help me take the guesswork out of these encoding decisions. Okay, X.264 preset. Anytime you either encode an FFmpeg or here's a GUI-based tool, you have the ability to use all these presets. Lot of, default is the medium preset. How do they differ in terms of quality and performance? And this is actually pretty interesting in a bunch of different perspectives, because when you're using X.264 for real-time transcodes in the course of like a live transcoding in the cloud situation, you're using super fast versus very fast because that's the only way to get to convert the files in real time. How much quality difference is there between that and say medium? And if medium is the default, how much quality are you losing compared to very slow? And and what's the performance? What's the time difference? So what I did in the book is I looked at 8 different files. 1 movie, Tears of Steel, the Blender, 2 animations. Why did I look at different types of videos? Because different types of videos encode differently. 2 general purpose videos. One's a music video, one's an advertisement. 1 talking head, just to look at a low motion video. And then for corporate and training people, I looked at screen cam and tutorial. So I have a Camtasia-based screen cam and a PowerPoint-based tutorial. And that's really something like this presentation, where you put a talking head on the right, and that's a video. And a lot of corporations use that. A lot of training shops use that. And then I measured with PSNR. I measured the time encoding. And this is what the result shows. So this is all of the presets that we saw across all of the files that I just talked about. And again, red is worst, green is best. Average scores are on the bottom. And then total delta is here. So total delta is how much total quality difference do you get between the lowest quality and the highest quality. So yeah, this is absolutely the worst. We see that. And even this is kind of a bit granular, hard to get information from. This kind of gives you a lot better information about it, right? This tracks encoding time. This tracks quality. So you can look at this graph and you'd say, okay, I pretty much want to start here, and this is going to give me, and this is on, we looked at this over here and we said, okay, there's 8.13% difference between here and here. And this is the scale of the 8.13%. Does that make sense? So basically this is saying that if you encode using I think that's faster. If you encode using the faster preset, you're getting very close. This is probably 6.5 to 7% of that 8%. You're getting most of the quality. So you never want to encode here, here, and here, because the time difference isn't that significant. You're really not gaining that much. And you probably wouldn't want to encode here as compared to here because you're gaining very little, and you're probably boosting your encoding time by a factor of 5. So this is the type of analyses. I can go to a customer and I can say, well, looking at your files, they may be movies, they may be any other type of content, and I can say, well, this is probably, you never want to go lower than here, and it probably doesn't make sense from a time standpoint to go here. And this is kind of interesting, right? Because you're saying, you're making the decision between buying a new encoding tool, which might cost $25,000 with the workstation, or cutting your encoding time by using a different preset. And what you're seeing here is you can go from medium to faster, which is maybe cutting your encoding time by maybe even a factor of 3, and you're losing very, very little quality. So you can translate that to, capacity, where if you're paying a cloud encoder to do it and you're paying by time, as you can with some of the pricing plans, you can translate this to savings. You can say, okay, I'm going to use the very fast preset because I'm losing very little in quality, but I'm saving a lot in time. So again, if you have all data encode, if you're Netflix doesn't care about encoding cost. They say, we distribute our files so many times that we want the absolute best quality at the absolute lowest encoding time. And I'm sorry, best quality, we don't care about encoding time. And that makes sense for them. On the other, so if you're Netflix, you could say, okay, we'll encode here, which gives us 100%. If you're a different shop and you just need, you care about encoding cost, you could say, okay, again, as we talked about, this gives me acceptable quality at a pretty fast encoding time. Okay, same analysis for keyframe interval. Here's 20 seconds, here's 1 second. I see a lot of companies who still encode with the keyframe interval of 1 second. This chart kind of tells you it's not that great an idea, but it also tells you that the difference isn't all that significant. And this is I'm using this with the video quality metrics, so lower scores are better. So this tells me I can use a general recommendation to use either 2 or 3, and that's going to be that's going to deliver most of the quality that you can get. And still work with your ABR formula. But this, a lot of people who see this say, yeah, it's time to change to 2 or 3. Reference frames, reference frames are how many frames you look through to find redundancies. The trade-off for redundancies is it takes a lot more time. So here you're looking at, okay, how much more quality do I get? How much more time do I spend encoding? So this covers the quality side. And 16 reference frames, yeah, that's kind of a big deal. It is the highest quality for all these video files. But the difference between 15 and 10 is 0.02% PSNR. And the problem with that is, here's the timing aspect. So 16 reference frames is 119 seconds on average. 1 reference frame is 51. So basically, you're cutting your encoding time by 60 to 65% here. And the quality delta is 0.34% on a PSNR basis. So yeah, it's correct, 16 reference frames is the best, but if you're running at capacity and you're faced with buying another computer to do your encoding, you might decide, okay, well I can go down to even 1 and put off that computer purchase for another 2 years, and the quality difference isn't going to be visible by the people who are watching my videos. So I pretty much, recommend 5. Again, 16 will give you better quality, but the quality difference isn't that great, and the time encoding is probably not worth spend. VBR versus CBR. Everybody says VBR is better. Yeah, VBR is better, but how much better is it? On average, it's pretty minimal. So here we're looking at 200% constrained VBR, 150% constrained, 125. 2-pass CBR, 1-pass CBR, and the total quality difference in some videos is pretty significant. Some videos it's not. But the problem with CBR is quality glitches. So CBR is constant bitrate encoding. You force the encoder to make some hard decisions. When that happens, you see spikes like this, and spikes like this turn into frames like this. So it's not only the average quality, which is what the number we see here, it's transient quality issues that we see here. And that's why a lot of streaming producers prefer not to use CBR. But the problem with using VBR, and this is a tool called Telestream Switch, which file would you rather send over a constrained connection? If you were charged with streaming over to mobile phones, if you send this file, you have potential data spikes that are going to really prevent from sending smoothly. CBR, very predictable, very easy to transport stream. So there's pluses and minuses. We see the quality benefit of CBR. You lose a lot in both still image quality at times, and you lose a lot in overall quality, but you gain a lot in deliverability. And what I've come to is I recommend 110% constrained VBR because it avoids the transient quality issues that we saw with CBR. It doesn't, the quality delta between that and 200% constrained VBR is not that significant, and it gives you a lot better deliverability. And I wrote a whole article about that on my website that's available here. And what I found basically is that there's very significant deliverability issues between 200% constrained VBR and CBR and 110% constrained VBR. Basically, the quality of experience with some files can degrade quite significantly if you're using 200% constrained VBR, precisely because of this issue. Because the encoder's having, or the player's having to switch streams so frequently that sometimes you get very low quality, sometimes you get very high quality. With CBR, they're going to stay with one stream, and that's going to deliver fewer overall segments, a higher overall quality of experience because you get a higher overall data rate of data. Anyway, that's available here. And then this is, when I'm building an encoding ladder for a company, this is kind of the approach I take. Number one, I choose, how low do you want to go? Are you offering this as an app on the App Store? If you are, there's some limitations there. Then I ask them to choose the top end. What's the highest supported data rate? How much do you want to spend? An hour video is going to cost you X at 5 megabits per second. It's going to cost you Y at 7 megabits per second. Can you afford that? And then I try and choose the data rate around 3 megabits per second because that's, Netflix publishes an ISP performance index every month that shows the average throughput for all of their video during prime time. Has anybody seen that? If you Google Netflix performance monitor or ISP index, you'll see it. Somebody take a guess as to the average best quality that Netflix is reporting, or best speed. 40? 4. Anybody else? 4 is actually a bit aggressive. It's like 3.6. So the Akamai reports that their average bandwidth is around 9 or 10, but Netflix is saying, and the thing about Netflix is that's the stream they're actually sending. So maybe sometimes that's not limited by bandwidth. It's just maybe that's the top stream. But if you're thinking 20 megabits a second, it's not sustainable. So I try and find a stream around 3 because I think that's going to be sustainable by most publishers. And then I fill in the blanks by trying to find ladders or rungs that are between 150 and 200% apart. So I pick, maybe the client says 200%, the max they want to go is 4,600, and I might and again, if you ask 10 people to do this, you'd get 10 different answers. So there's nothing magical here, but this is about 2.5%, this is about 2.5x, 2x, 1.6x, so I'm coming up in pretty big chunks. And then the question is, what's the best resolution at each data rate? And this is the per title approach that Netflix used. Basically, what you do is you measure PSNR at a range of resolutions and a range of data rates. So in this case, I would look at 1080p, 720p, all these at different ranges here. And then I would choose, this is the highest score for each. So each rung here, the green is the highest score, and these are the rungs that correspond with the data rates that I chose for my encoding ladder. So that's how I would go about choosing an encoding ladder. I'd pick the data rates first and then choose the resolutions, and the resolutions would be based on an analysis that's like this. And again, this is not something you can easily do without objective quality metrics. And choosing, this is an interesting, what does this chart tells you? This chart tells you, here's the best quality, the 1080p, and as the data rate gets lower, 720p gets better here, and then 540p gets better here, and then 360p gets better here. What does the fact that these are never the best quality tell you? Maybe it's time to start thinking about dropping your 180p and 270p streams because they're never the best quality. And then if you look at this for HEVC, it's even stronger. You don't have the same encoding ladder for HEVC as you do for H.264 because you're dealing with totally different, you're dealing with much better compression. So a lot of clients that I work with are starting to abandon the lowest rungs on their encoding ladder because they never deliver the best quality. So you're just encoding streams that nobody should ever see. And then this is VQM, so lower scores are better. This is an analysis that I like to understand, how low can I go? So if I have a movie client or a Netflix competitor, we'll look at X video files, we'll encode them, and we'll code them at specific data rates, and we'll kind of see what's the lowest you can go for 1080p, and then we measure the quality. And this is the SQM score that we saw a few minutes ago. So anything above 80 is supposed to be excellent quality. So if you're streaming your videos at 7 to 8 megabits per second, yeah, the quality is excellent, but you're really not going to start to see a major drop in quality for some of these videos until you're in the 4 to 5 range. And I heard who saw the talk today by the gentleman from Major League Baseball? So his top speed was what? It was 4.5 megabits per second. So if you look at the video here, that number looks pretty strong. He still should have pretty excellent quality video. And that's what these numbers show as well. And then the whole per title encoding thing, how do you change your results based upon the quantity, the type of content it is? So here you look at a real world video and you basically see, okay, the quality of the real world video is 91.48 at 8 megabits. I get 91.48 for the animated video at 5600. So I think at this point everybody should be pretty clear on the fact that if you're using the same encoding ladder for very disparate types of content, then you're leaving some bandwidth on the table. And what we're seeing here basically is that I can get 90 quality for an animation at a significantly lower data rate than I can here. And same thing over here, I get 87.72. That's the same score here at 33% data rate savings. So again, long way of saying you really do need to be encoding your video differently based on content. And then finally, this is a slide. I'm benefited to have a good relationship with HP. I test a lot of their equipment, and I use a lot of their equipment. When you're doing a lot of these analyses to convert to YUV, which you need to do for some benchmarks, you're going to see a very, very significant decrease in conversion time and metric processing time if you have an SSD drive and if you have a pretty dense multi-core solution. So if you're trying to do this on a regular hard drive, you're really shooting yourself in the foot because it's going to take much, much longer than it would on an SSD. These are the only reasons they have SSDs. If it's compression or something that's not real time, you don't really care. But if you're doing anything that's very, very disk intensive, as all these what these are is they're converting the files from compressed to YUV, which is a very high data rate format. Then it's comparing it to the source file and doing the same thing for that. So it's doing a lot of pulling data from the hard drive, and you see a huge difference in processing time. Any questions? Okay, let's call it. Oh, sorry. You're really, if you're encoding to measure with PSNR, you should tune for PSNR. If you're encoding for the other ones, the more advanced, you'd have to talk to the vendor and the codec vendor. I don't know which sessions you were at of mine. We looked at this with VMAP. I spoke to the developer of X264, and I said, should I tune for PSNR if I'm testing with VMAP? And he said no. And then I didn't, and the scores were pretty low as compared to main concept, so I did tune, re-encoded again, retested again, and found the scores were much higher. So I don't know what that means, and that's something I need to go back and kind of figure out. But that whole tuning and non-tuning is, the more perceptual you get, the less you should have to tune. But if you're looking at PSNR, you definitely should tune, because what the developer says, what the codec developer says is, we use perceptual adjustments that decrease our PSNR score. So when we tune, we take those out. So that's why you would do it.
One of the subjective quality tests that you showed had options for different makes and models of TV.
Yes.
Tablet or whatever. Can you talk about what those differences would be? It seems like the bits should be the bits.
Well, I mean, the differences would be, screen brightness, distance viewing, resolution. So you look at your iPhone from here. You look at a TV, maybe even from this distance. So it would take a lot of those factors. Size, I think, is a really big one. Again, an 854 by, I spoke to Netflix at NAB, and I think they're doing downloadable files for mobile now. So what resolution do we think they're downloading at? Or encoding at for their downloads? Mobile downloads, Netflix. What resolution do we think they're using? 480p. Anybody else? 720p. It was like 512 by 288. So why are they doing that? Because they figured out perceptually that gives them reasonable quality on the tablets. So to answer your question, that looks great on a tablet or on a smartphone, but if you blew it up on a 60-inch 4K TV, it would look awful. So you really, and there are pretty standardized ways to build that into a metric. So I don't think Netflix is going to have trouble getting there, but I think it's a nice value add.
When you showed your bit rate, like the ladder you had, like on the lower spectrum, you actually had like a 2.5 factor. Some of the vendors who recommended it say like on the lower bit rates actually to have smaller like ladder, and when you go to the higher bit rates, that's when you can have a little bit bigger, I guess, within 200%. Choose it the other way around.
Like I said, I think if you ask 10 encoding professionals, you would get 10 answers for something like that. So I don't disagree with that. I think I'm seeing fewer and fewer customers care about. If you're in, VNova is a company that sells a codec called Perseus. Perseus' specialty is low bit rates for distribution in companies that are sold mostly cell phone driven with 2G and 3G. So they would probably agree with you. I think in America, where bandwidth is, even mobile bandwidth is good, I think there's a lot less concentration at the low end. But I think, geographically, you need to factor in who's viewing. Certainly for corporate America, I think they don't care that much about the low end. I don't want to say that. Everybody's different.
On the graph for the preset, you show the ultra fast and the slow. And the difference between the quality with PSNR was very low, like 2% up to 2%. But in a subjective, I'm using the ultra fast for the proxy. When the user uploads video, I'm putting them the ultra fast as a quick video. And I found that the quality is extremely bright compared to the, for instance, medium, where I'm transmitting for the normal users. So is it really, 2% you said it's very low, so is really PSNR that can tell you the quality?
Good, it's a good question. I think anything you do, you're going to have to back up with subjective. And that's a great. I'll probably go back and rerun those tests with VMAF and see if I can see a bigger difference. Because I think you were at the session yesterday. VMAF seemed to show a greater sensitivity at the lower end than what I'm seeing with PSNR. But you're right. Sometimes it does seem like it's more visible than what that's reporting.
You mentioned the Apple requirements for the HLS spec.
Say it again?
The Apple requirements for the HLS spec.
Yes.
Encoding ladder. I'm a bit confused as to the lowest. You need to have something below 192K, right?
That's it. It needs to be 192. Did they remove the audio?
That's the question.
I think they did, because I looked at that and I couldn't find the requirement to the audio, and I know it used to be there. So the latest that I found was 192, and it had to be pretty. They define it pretty well in that new Apple HLS specification document. So.
You can do decent video at
Yeah, it's got to be, it's got to be both. So,
It's great if you're, like we are looking to transcode large library.
well, I mean, Apple has recommendations, right? They tell you what the video and the audio can be. So if, I would default to those in the absence of anything.
So you mentioned that you're trying to YUV for testing, right? So you have considered only the grayscale, the lighting, and the color layer, or you have considered all the layers, the color layers?
Good question, because you can run the tests upon any layer that you want. During the conversion, you're converting all of them, but the PSNRs I think are mostly run on Y. But you can choose with the Moscow University tool, you can choose that on a metric by metric basis. Okay, thanks for your attention.